All right, today we're going to dive into a pretty radical new theory. I mean, this thing sits right at the intersection of quantum physics, biology, and cosmology. It's called the information-based coupling of life to the cosmos. Yeah, it's a mouthful, so we'll just call it ICCLB, and it proposes something that is truly mind-bending about life's role in the entire universe.
So let me ask you something. You know that thin, slimy film of algae you see on a rock? Or the waxy skin on a leaf? What if they share a fundamental secret? What if they aren't just these passive surfaces we see every day, but are actually part of some vast living network? Well, here's the core idea of ICCLB. It claims that these surfaces are constantly listening to the quantum world, the weird, fuzzy reality of the super small, and translating its whispers into our reality. And get this, in doing so, they might be subtly weaving brand new information into the very fabric of space-time itself.
Okay, so you're probably thinking, how could that possibly work? It sounds like science fiction, right? Well, to understand it, we first have to start seeing life as a kind of quantum translator. The whole theory starts with this concept called a living boundary. Now, this isn't some mystical idea, it's a real physical thing. We're talking about microbial biofilms, the cuticles on plants, maybe even huge carpets of pigment out in space. They're all these structured biological surfaces, and the key is that they host special, spin-sensitive molecules. Just think of them as billions of tiny, tiny compass needles that can be flipped by quantum events. So this translation process happens in 3 basic steps. First, some tiny quantum event happens, like a particle's spin flips on this living surface. Second, the boundary acts like an amplifier. It takes that microscopic flip and turns it into a real, classical signal we could actually detect, maybe a tiny flash of light. And finally, when you have billions and billions of these events happening all the time, they create this constant stream of data, what the theory calls an information flux. But where does all that information go? I mean, it can't just disappear, right? This brings us to the next crucial layer of the theory, turning that flow of information into an actual message. And here is the absolute kicker. The theory proposes that this constant flux of information isn't just lost as noise. It actually sources a whole new kind of field. They call it a boundary field. It's what's known as an effective field, one that emerges from the collective hum of all these living surfaces. And this isn't just some passive theoretical field. As the paper itself says, this accumulated information could then affect the world on a much larger scale. You see, this boundary field would carry its own stress and energy, which in physics is just a fancy way of saying it has influence, it has a presence. In principle, it could physically interact with the world around it. Now, the theory even proposes a new constant. They call it kappa B, that links this field directly to spacetime. Okay, look at this number. It is absurdly, ridiculously tiny. It's about as close to 0 as you can get. But the most important thing about this number is that it is not 0. It suggests a real physical link, no matter how faint, between the information generated by life and the actual geometry of our universe. This is where it all moves from being just a fascinating idea to becoming testable science. Because if this effect is real, even if it's incredibly weak, it should leave behind detectable echoes. And the amazing part is, we should be able to find them in the lab, in our cities, and maybe even in the light from the Big Bang itself. So the challenge really is to build the right kind of microphone to listen for these echoes. And what's great is that the theory proposes very specific tests with clear, measurable signatures. That's exactly what you want from a good scientific hypothesis. So the experimental program they've laid out spans 3 totally different scales. In the lab, you could use these hypersensitive diamond sensors to listen for a tiny frequency shift happening underneath living algae. In our cities, we could set up an experiment to look for subtle changes in polarized light bouncing between buildings. And at the largest scale imaginable, we can actually search for strange, unexpected patterns, anomalies in the cosmic microwave background, the afterglow of the Big Bang. Let's just zoom in on that Twin Street experiment for a second because it is such an elegant idea. Imagine 2 identical streets right next to each other. One is covered in life, ivy, biofilms, you name it. The other one is totally sterile, just clean glass and concrete. The theory predicts that on the living street, a standing wave of polarized light should appear. It's a signature that should be completely, totally absent on the sterile street. Simple and brilliant. And of course, to make sure they aren't just fooling themselves, the whole framework is built with rigorous controls. You swap the live and sterile samples in the lab to see if the signal follows the sample. For the twin streets, you could even swap their roles weekly. For the cosmic analysis, you rotate your view of the sky. These are called null tests, and they're designed specifically to rule out false positives and give you real confidence if you actually find something.
So, okay, we have a mechanism, and we have clever ways to test it. Let's move to our final section and really look at the big picture. What does this all mean for life's role in the universe?
To help us wrap our heads around the more profound implications, the authors use a really compelling metaphor. And if you're a sci-fi fan, you're going to love this. They compare it to the spice from the classic book Dune. Just like the spice in the book was this substance that expanded consciousness and let people navigate through space-time, this biological information flux could be a kind of natural resource that subtly shapes reality.
And the theory also opens the door to some really wild, speculative ideas. For instance, the mirror principle suggests that two facing living surfaces, like the sides of that street canyon, could actually amplify these signals. Dream phase coupling asks if maybe our brains during REM sleep become more sensitive to this information field. It even speculates that life might filter for patterns based on special numbers, like prime numbers or the golden ratio. Wild stuff. So, what's the ultimate takeaway here? If this theory holds even a tiny shred of truth, it reframes, well, everything. It suggests that life is not just some passive passenger, just evolving by chance in a cold, dead, clockwork universe. Instead, life becomes an active participant, a co-author of reality. It's constantly generating information, and that information feeds back into the cosmos, weaving itself into the very structure of reality on the most fundamental level you can imagine. And this leaves us with one final, provocative question. Could it be that the grand story of the universe isn't just written in the light of distant stars and galaxies, but also in the quiet, persistent, collective hum of every living thing?